Okay, so this is question number 11 in common part of TIFR exam this year. And in this question, we are provided with the series. If you observe the series carefully, you can understand that um, in first term it is written as 1 upon 2 square minus 1. Then in second term it is 4 square minus 1. Then it is in third term 1 upon 6 square minus 1, which is 2 into 1, 2 into 2, 2 into 3. So generalized term is 1 upon 2n to the square minus 1. So this is the general term given here. And if we break this general term, it can be written as 1 upon 2n plus 1 into 2n minus 1 by this formula, a square minus b square is equals to a plus b into a minus b, right? So if this is the general term, then you can understand that here n's value was 1, here n's value is 2, here n's value is 3. So here n's value must be 20, right? Because 20 into 2 square minus 1, last term can be written like that. So this whole sum can be written as n is equals to 1 to 20, and general term is 1 upon 2n plus 1 into 2n minus 1. Now to apply any formulas like summation of n square or summation of n cubes formulas, we actually have to find out the partial fractions of this term. I have to separate these denominator terms here. So to separate these denominator terms, I can write these terms as a upon 2n plus 1 plus b upon 2n minus 1. So by taking this as LCM, a into 2n minus 1 plus b into 2n plus 1. Okay, and where I was, okay, here, and that is equals to 1 upon 2n plus 1, 2n minus 1. So by equating, I can say that this is actually equals to 1. So a into 2n minus 1 plus b into 2n plus 1 is equals to 1. That means 2n into a plus b minus a is actually equals to 1. Alright, 1 plus, you can write as 0 into n. So if you will compare this constant term with this one and this variable term with this one, you can write as a plus b is actually equals to 0 and b minus a is actually 1. So after solving it out, you will have this, and b is equals to 1 plus a. Okay, so minus a equals to 1 plus a. I have used this here, b is equals to minus a, and a's value will be now, I guess it will be minus 1 by 2, right? And b's value will be 1 by 2. So let me just create some space here. Now I can write as summation of n is equals to 1 to 20 is actually equals to a's value is minus half, so minus 1 upon 2 into 2n plus 1, and this is 1 upon 2 into 2n minus 1. Okay, and I can take this 1 upon 2 common as below, and is equals to 1 20. This is minus 1 upon 2n plus 1, and this is 1 upon 2n minus 1, right? So first term can be well written as don't look for this, actually this part will be common in every term, so just observe on this term only. So t1 will be 1 upon, actually it will be minus 1 upon 3 plus 1 upon 1, right? t2 will be minus 1 upon 5 plus 1 upon 3. Okay, and t3 will be minus 1 upon 7 plus 5, right? So if you observe carefully, these terms are getting cancelled by the term just consecutive itself. So if you look at the final terms like t19, it will be minus 1 upon 39 plus 1 upon 19 to 37, and t20 will be 1 upon 41 minus 1 upon 41 plus 1 upon 39. Okay, so this term is also getting cancelled, and as you've seen above, the second term is also getting cancelled by the term precedent of itself. So in the end, what we will get is summation n is equals to 1 to 20. This is 1 by 2, and this will be remained as actually I have calculated this sum, so 1 upon 2 into 1 minus 1 upon 41. So this term is remained and this term is remained only, right? So 1 upon 2 into 40 by 41, and after cancelling it, it is 20 by 41, right? So option A is right, which is option 1. So that's the answer.